Good day, everyone. Trust your day is good. Today we are moving to differentiation, and it is because we are jumping. We're supposed to enter limits, but because of those that need it for their whole day in 200 level, that is Math 202. So as to help them recall what differentiation and integration is. So this one will be based on differentiation, and integration will be dropped tomorrow. Okay. Now we have differentiation. Okay. let me recall what let me help you recall what differentiation is. Okay, let's say you have y is equal to x squared. How will you differentiate? You just say the power multiplied by the coefficient, which is 2, and your x, rewrite it, subtract 1 from the power, and that one will give you what, that is 2x. Assuming you're asked to differentiate 3x cubed, you just say 3 multiplied by the coefficient, which is what, 9, x 3 minus 1 will give you 2. So that's how to differentiate. Okay, now the first one we are going to talk about in this one is what? Functions of functions. That is the what? It can also be called the chain rule. So how are you going to go about this type of what rule? Okay, chain rule let us know that the formula, that is the y over dx, is equal to what? The u ds multiplied by I'm coming, the u dx multiply by dy du. And it is not that it is a standard something, because they may not use y to represent what you are doing sometimes. So you will know how to use this formula, how to know it, how to prove it out. Like when you are solving questions, you may have dm ds, you may have dv not dx itself. So that's how it works. Okay, but x is just a common variable that we most use when solving problems on differentiation and integration. Okay, now we have the y ds is equal to the u ds multiplied by dy du. Okay, how does function of function, how will you know that, oh, this question I'm going to use function of function for it? Is that when something, like, let's say a trigonometric function, like, let me talk about the trigonometric. Let's say cos x. Now, cos x can easily be differentiated by saying cos x is equal to what? Minus sine x. Okay, but assuming you now have something like cos ax plus b, this one is different from, you can't just say sine x is equal to, differentiation of this one is minus sine ax plus b. You can't just say that, because this one has changed from the what standard one that we used to follow. So that's how you will know, okay, I'm going to use function, because is that when trigonometrics. So let's say that maybe you have exponential function to e raised to power x. You should know that to differentiate e raised to power x is still the same thing as e raised to power x. But assuming that you have something like e raised to power 2x plus 2x squared plus 5, you can have something like this. You can have e raised to power 2x. It has differed from the what standard differentiation that you used to use. Okay, let's say you have e raised to power cos x, you can have something like this. So it means that this one is no longer the standard. You can't say e raised to power cos x is equal to e raised to power cos x when you differentiate it. Do you understand? This one at what? This one is a standard differentiation. Like, standard differentiation of exponential with respect to x is equal to the exponential with respect to x. But here now you are having a trigonometric functions raised to the what? Power of an exponential function. Okay, so it means that your formula is going to change. You can't just say that when you differentiate exponential raised to the power of cos x, you can't just say it is equal to the same thing. Do you understand? So it means that when you find yourself in this kind of situation, you are going to use chain rule. Okay, assuming that you have something like this too. Let me remember. Okay, you have something like y is equal to square root of 3x squared plus 5x plus 1, something like this too. You will have to use chain rule, because you can't just differentiate this one directly. This square root will make you to use what? Chain rule, because you can't just differentiate everything like that. Do you understand? So How are you going to go about it? You are going to learn in this video. Make sure you subscribe to the channel for more tips and other courses. Okay, function of function. Okay, this is the formula. In, let me start from the what easier one. Y is equal to, let me say, cos 2x plus 5. So how are you going to differentiate this? Just know that for you to differentiate, you just say that, okay, let's you should be following. It is not compulsory for you to be using u or something. You may use m. Just make sure that this your formula will change whenever you use a variable apart from u. Do you understand what I'm saying? So let u is equal to 2x plus 5. Okay, you differentiate it and you remember how to differentiate. Is equal to what? 2. Okay, now you now go back to this what your function that they give you, the original question that they give you. It will now be y is equal to cos. What do you use this one to represent? You use it to represent u. Abi, cos u. You know this one you can easily differentiate it. You can say dy du, because you are differentiating y with respect to u. Assuming that m is here, it will be dy over dm. What you are differentiating at the left hand side will be divided with what you are differentiating at the right hand side. Okay, assuming you have y here, you have n here, it means dy dn. That's it. So dy du will now be equal to what? Minus sine what u. You understand? So, and you remember your formula that dy dx is equal to what? Du dx multiplied by dy du. Your du dx is what? 2 multiplied by your dy du is minus sine u, which means that 2 minus 2 sine what u. But your u is what? If you remember, 2x plus 5. 2x plus 5. So it is what? Minus 2 sine what? 2x plus 5. Okay, now let me now give you the trick so that you won't be stressing yourself whenever you are solving questions. Like, it may come out like you will be solving questions and you will just come across it. So how will you do it? You just say that differentiate this inner one. Do you get what I'm saying? Differentiate the inner one of that function. Like differentiate 2x plus 5, you get 2. Write that 2 out. Differentiate cos. You know, I did not say differentiate cos 2x plus 5. I said differentiate cos. You get what? Minus sign. And rewrite what is inside here. 2x plus 5. I'm sorry, I don't know you are not seeing it. 2x plus 5. Let me repeat again. The trick to do whenever you come across this one, you are solving questions. Okay, so you will say that differentiate this inner one, you will get 2. Differentiate cos, you get minus sign, and put this one back for sign. Now do you understand? So you will get what? Minus 2 sine what? 2x plus 5. So that's just how to do it. Okay, let's move on to another question. Now we only solve 3 questions for this one. 3 questions only. Okay, question 2. Let me take let y is equal to 3 tan raised to power 4x. Okay, how will you solve this kind of question? Okay, you should know that 3 is just a constant, so you don't need to worry yourself about that, and you won't throw it away. I did not say that you will cancel it though. Like, you don't need to stress yourself. You can always add it when you get your final answer. Okay, now you will just say, you know that this one is raised to power something, and you know that in our standard differential derivative, derivative of what x squared will give us tan x. Do you understand? So, and now what do we have to do? Because you have raised to power 4 and there is no standard what? Standard derivative for tan raised to power 4x. There is no standard. It means you have to use what? Chain rule to solve this kind of question. Okay, so you just say let u is equal to tan x. You will be wondering why I make use of what? Tan. Because that is what is what? Because I can always express this one as 3 tan x raised to power what? 4. I can always express it as that. So I can say the inner one is equal to what? Tan. So you should know that du dx of tan, do you understand? So it will give us what? Du dx will be what? Sec square x. Now you go back to your original question, which says y is equal to 3 tan x raised to power 4, right? So you can say that y is equal to what? 3. What do you use tan to represent? U raised to power 4. Now you differentiate. It will give you what? The power multiplied by the coefficient, which is 12. U raised to power 4 minus 1 will give you what? 4 minus 1 will give you 3. So you can always say that dy dx is equal to what? Du dx multiplied by dy du is du here. Okay. Now, so dy dx is equal to what? Du dx is what? Sec square x multiplied by dy du is 12 u raised to power 3. But you should know that your u is represented by something, which is what? Tan x. So your answer will be what? 12 tan 3x sec square what? X. So that's your what? Answer for this what? Question. If you differentiate tan, you get sec square x. That's the fact. I will write out the what? The formula sheet for derivatives that you have to know. Okay. Now let me solve the last question for you on chain rule. Okay. Let's see question 3. Let's say we have something like e raised to power cos 2x. E raised to power what? Cos 2x. How will you differentiate this one? Okay. You know that you will have to use what? Chain rule. Okay. You just say let your u is equal to what? Cos 2x, right? So if your u is equal to cos 2x, how will you go about it? You have to differentiate du dx. Now you should know that cos 2x, we also have to pass through the same process of differentiating it with what? Of differentiating it with what? With chain rule. But you don't want to do that. That's why I give you the trick earlier on how to solve it. You will just say that cos 2x, differentiate the inner one, which is 2x, you get what? 2. Differentiate cos, you get minus sine, right? And rewrite this 2x again for sine 2. So you get that your du dx is equal to minus 2, I mean sine what? 2x. Simple as ABC. So now you get your du dx, you go back to the function that y is equal to what? E raised to power what? U. Because your cos 2x is represented by what? U. You get that your dy du, because you are differentiating with respect to what? U is equal to what? E raised to power u for exponential. Okay, because it's the same thing. You can't be saying that it's only for x, so it can be any variable. E raised to power a, the derivative of e raised to power a is equal to e raised to power a. Okay, now dy over du is equal to e raised to power u. So you should remember that dy dx will be equal to what? Du dx multiplied by what? Dy du. Okay, and you know that your what? Dy dx will now be equal to what? What's your du dx? Which is what? Minus 2 sine 2x multiplied by e raised to power u, which is our dy du. So we have that, and your u is what? Cos 2x, which is minus 2 sine 2x e raised to power what? Cos 2x. So what I want you to know in this kind of question is that you can have a question that you will be required to use chain rule twice. That is, before you solve that question finish, you will use chain rule twice. Assuming that you did not know the trick for this one, you will have to use chain rule twice. But because you know the trick, you just solve it directly like that. Do you understand? So that's that on what chain rule. Question will be dropped for you so as to solve and to test your knowledge on whether you understand the concept or not. Now let's move on to what product rule. Okay, what do you understand by product rule? Product rule, you will use product rule. It will occur when you are testing, like when let's say that okay, you are given a function x, you know this one is a what, polynomial function, so of degree what, 1, multiply by, let's say, a trigonometric function like this, or you have something like ex cos x, you have to differentiate. You should know that these two are like the exponential and the trigonometric are joined together by what, by multiplication. That's why we call it product rule. They are joined by multiplication. Do you understand what I'm saying? It is different from what's this called, and chain rule, because for chain rule now, let's look at this question. You can't just say that this cos you can split 2x plus 5 and cos you can't split them, because cos this 2x is what, for it's like representing this 2x plus 5 by x. It stands for x, or let's say y. Do you understand? Or m. So it is just that inside the what, cos, it is just that inside the cos you have a what, a polynomial function or a linear function. Do you understand now? Okay, let's move back to what we are doing. So product rule now. So polynomial, okay, they will be joined by multiplication. That's how you would make sure you know all these things, because these are the basic things that you have to know before you start solving question on ODE. Okay, now the formula, okay, sorry, is equal to what, dy dx for product rule is equal to phi du dx plus u dphi dx. Okay, phi du dx plus u dphi dx. Okay, how will you go about this one? So it means that okay, let's start solving question on product rule 2. Okay, let me take out some question like, let's say we have find the y dx when you have a function like 3 root x ln 2x. 3 root x ln, you have to differentiate this type of function. Okay, now you should know that ln is a what, family of logarithm, and this one is like a, let's say, an equation like 3 root x. You can say linear, you can say polynomial, or any one you want. Okay, because they are joined by multiplication. You can't say that this one, like, they glued together. They did not. Ln is glued with 2x. It's like saying log 2x. Ln is the same thing as log. You understand? Okay, now what are we going to do whenever you see this kind of question? You are going to make the first function as your u and the second one as your phi. Now you get your u and you get your phi from the what, equation that you are going to use from the formula, but it remains du dx and dphi dx. How are you going to get it? It means you are going to differentiate u and you are going to differentiate phi. So your du dx is equal to what? You know how to differentiate. This one can be expressed as what? 3x raised to power half. You understand? So just say half multiplied by 3. That's what? 3 over 2 x raised to power minus half, because you subtract 1 from the power, and it can also be expressed as what? 3 over 2 root x, because I can bring this s coming down and this negative return to positive when it gets to the what, denominator, so you have positive root. Okay, now we have 3 over 2 root x. Now for phi to the phi dx will give you what? If you remember the chain rule, you understand? If you remember, you have that you differentiate the inner one, which is 2, multiply by, you understand what I'm saying? Now you have that u is equal to what? 2 raised to power what? And 2x, you differentiate 2x, you get what? 2. So multiply by, you know, you have what? Ln u now, because this one you are going to use what? Chain rule to solve it, but because of the trick that I taught you earlier in the what, at the beginning of the video, you should be able to understand how to do it. And you know that to differentiate lane u, because this one is represented by u, like something, differentiate lane, you have 1 over, and we represent it by u, so 1 over u, it means that you have 1 over what? 2x. If you use chain rule for it, you should be able to get it. So 2 will cancel 2, you have what? 1 over x for the what, derivative of ln 2x. Now you can move on to your what, formula to simplify further. you have that the y over dx is equal to phi du dx. Your phi is what? Ln 2x, and your du dx is 3 over 2 root x multiplied by ln 2x plus phi u dv. U dv, which is what? 3 root x multiplied by 1 over x. So you simplify further, dy dx will be what? 3 ln 2x over 2 root x plus this one is raised to power 1, this one is raised to power half. You can use law of indices. Half minus 1 will give you what? Half. So you have 3x raised to power minus what? Half. Okay, so you can say express this one as what? Dy dx is equal to 3 ln 2x over 2 root x plus 3 over what? Root x. If you wish, you can factorize 1 over root x out because it is common to both sides. Even 3 over root x is common to both sides, so you have something in your bracket. So that's how to differentiate. Okay, let's move on to the second question. Okay, the correct second question will be in form of, okay, I'm coming, question 2. Okay, let's pick a function. Okay, let's say we have something like 2x raised to power 3 plus 5x plus 5x squared plus 2x plus 1 multiplied by sine 2x. You should know that this one is the multiplication of what? A polynomial multiplied by trigonometrics. So it means you have to solve this one too, and you are going to use product rule because they are joined together by what? Multiplication. So you have that your formula, don't forget, dy dx is equal to phi du dx plus u dphi dx. Okay, now from what I taught you earlier, this one is your u and this one is your phi. So you have to differentiate to get this one and this. So du is equal to what? Differentiation of this one we give you what? 6x squared plus 10x plus 2, right? 6x squared, you know how to differentiate, right? And okay, du dx, and your dphi dx, this one you will use what? Chain rule to solve, because it is not just normal sine x, it is now sine 2x. Like it's like a what? Function inside x, sine. And what will you do? I already told you about the trick that what are you going to do? You are going to differentiate 2x, which is what? 2, multiply by differentiate your sine, you get what? Cos, and rewrite that 2x back for cos 2, and you get 2 cos what? 2x. Do you understand? Okay, now it means that you are going to have your dy dx using your formula will be equal to what? Phi du dx. This is your phi, this is your du dx. You have that 6x squared plus 10x plus 2 phi du dx plus u, where is your u? Our u is this, 2x cubed plus 5x squared plus 2x plus 1 dphi dx 2 cos 2x. So this is what? Derivative of what? This type of function. Let's say y is equal to this. So that's that. Under that too, make sure you go through your textbook, work out some problems, and that's how you what? Make a progress on this topic. Okay, let me move on to the third one. Okay, let's say we have something like x raised to power 3 cos 3x ln x. Now x raised to power 3 cos 3x ln x. How are you going to differentiate this one? Because this one, it is like 3 functions inside one equation or one expression. Because let's say y is equal to this, because this one is a what? Polynomial, trigonometric, and logarithms. Okay, so how are you going to do it? Because you have 3 what? Functions inside y. Okay, now make first combine this one to be your what? U, and this one to be your phi. U phi. Now your u is equal to what? X raised to power 3 cos 3x. You want to find your what? Du dx, right? How are you going to do that? Your du dx, how will you express that? It means that you should look at this expression you can only solve it when you use what? Product product rule, because it's the what? Combination of what? Polynomial and what? Trigonometrics, and they are joining by multiplication. So it means you have to first solve this one using product rule to get your du dx now. And this one, sine 2x2, is for chain rule. You have to use chain rule. That's how it is differentiation. You can use three methods to solve one problem. Okay, now how will you solve this one? How will you simplify it? This one will be your what? Using what? You are using what this called? You are using product rule to solve, right? Okay, now you have your u to be this. You can see, let my what? Let this one be n. You can change your variable and this one be n. So it means that this is your what? U, this is your phi, according to your what? Equation that you have. According to this equation, the first one will be your u. You can put it small so as not to be confused. Okay, now what are we going to do? You differentiate m, right? Which is what? Dm with respect to dx is equal to what? 3x squared, and your n with respect to x2 is equal to what? Remember the trick, differentiate the inner one, which is 3, multiply by minus sine what? 3x, which is what? Minus 3 sine what? 3x. Okay, now your du dx, now du with respect to dx will be what? Phi du dx, your phi du dx, which is what? 3x squared cos 3x plus u d phi dx, u d phi dx, which is what? X cubed minus 3 sine 3x. Okay, so you can simplify this one further by saying that your du dx is equal to what? 3x squared cos what? 3x minus 3x cubed sine what? 3x. So this is your what? Du dx. Now you just differentiate your what? U now. Now let's do for phi too. Remember that your phi is equal to what? Cos, oh, our phi is ln x, sorry, ln x. So the phi dx will be what? 1 over x. Remember the standard what? Derivative of this one, 1 over x. Now after getting 1 over x, what are we going to do? You are going to go back to your formula by saying dy dx is equal to phi du dx plus u d phi dx. I believe you will now have all this, so you can substitute. So our phi is what? Ln x multiplied by du dx, which is what? 3x squared cos 3x minus 3x cubed sine 3x, everything multiplied by ln x, plus your u. Our u is what? Plus u is x cubed cos 3x multiplied by dv. So I can say this one, it remains squared, and which is now equal to, I can factorize 3x squared out here. So I have 3x squared open bracket cos 3x minus x sine 3x ln x plus x squared cos 3x. So this is your final answer when you have to differentiate this what? Type of what? Question. So make sure that you know how to what? Go about everything on that product. You make sure you solve questions so as to familiarize yourself with how questions comes. Okay, now the other rule is what? The quotient rule. The quotient rule. Okay, now the quotient rule deals with division, like division rule. Okay, whenever you have, let's say, y is equal to f of x over what? G of x, it's like a rational something. Okay, so it's division. Whenever you have a function divided by another function and you have to differentiate, make sure that you know that it is, you are using what? Quotient rule to solve. Okay, let's say okay, the formula, okay, dy dx is equal to what? Phi du dx minus u d phi dx all over what fixed square. Okay, so this is the formula we are going to be using for quotient rule. How will you know? I already explained. They will come in form of fraction. In form of fraction. Okay, now let's start solving question on that one too. Okay, let our first question be y is equal to t e raised to power 2 all over 2 cos t. T e raised to power 2 over 2 cos t. How will I differentiate this one? Okay, you should know that the what the numerator will always serve as your u and the denominator as your what phi. Okay, now from your what formula, you should know that you must get your what du ds and dv ds before you can solve any question. Okay, so our u is equal to what t e raised to power 2. Now I want to get my du dt because you are differentiating with respect to t, du dt. Now how will you get your du dt? Because this one you can't use, it can't be, you can't just differentiate by saying 2 multiplied by the constant. No, this one looks like a what you are going to use product rule to solve this kind of question. Okay, so product rule, you are using product rule because is this t is like a polynomial function and you have an exponential function, so you are using product rule to solve this kind of what question. And using the product rule, this one is will serve as your what m and this one as your n. I will not waste much time on it because we already explained how to do that. So I have my dm dt because you are differentiating with respect to t is equal to 1, and my dn dt. I already told you about the trick. Differentiate the what this one because you can't just say e raised to power t is equal to e raised to power t. Let u is equal to 2t. Differentiate that 2t, you get 2. Rewrite the function again and put 2t. That's how we do it. Okay, now you have your what dm dt and dn dt, so I can say that my du dt is equal to what, this is my u, this is my phi, right? So phi, okay, phi du dt, and which is what dm dt is equal to e raised to power 2t plus t multiplied by this one, which is 2t e raised to power 2t. You know that's how I did. This is your u and this is your dphi. So u dphi dx in the formula, but here you are using t. That's why I'm saying it like that. Okay, so I already differentiate my du dt. Now for my phi 2, which is what 2 cos t cos t. So I have that my dphi dt will be what minus 2 sine t. Now I can substitute in the what formula by saying that dy dt is it, because it's no longer dy dx, you are differentiating with respect to what t. Okay, so you have that dy dt is equal to what phi du dt plus oh minus, because this one is quotient, minus u dphi dt everything over phi squared. So you have that what's our phi 2 cos t, and our what du dt is what this one, so 2 cos t into e raised to power 2t plus 2t raised to power 2t minus our u is what t e raised to power 2t multiplied by our dphi dt, which is what negative 2 sine t everything over what phi squared, which is what 2 cos t everything all squared. So you have that 2 cos t, you can factorize e raised to power 2t out because it's common to both functions. So you have that 1 plus 2t into e raised to power 2t plus, because of this negative, plus t e raised to power 2t, okay, 2 multiplied by, okay, sine t everything over what 4 cos square what t. Do you get what I'm saying? So okay, let me still simplify this thing further by saying that I have which is equal to what, I can still factorize e raised to power 2t out in both functions, so e raised to power 2t can also come out. No, even 2 e raised to power 2t can come out. So I have that 2 e raised to power 2t open bracket. Here now it will remain what, if 2 e raised to power 2t come out, cos 1 plus 2t. Okay, let me put this one, cos t into 1 plus 2t. Okay, plus t sine t everything over 4 cos square t. So 2 can cancel 2 here, it remains 2. Okay, 2. So we have that I have that e raised to power what, 2t into cos t into 1 plus 2t plus t sine t everything over 2 cos square what t. So these are our what, final answer. So that's that under quotient 2. In the next video we'll be talking about the implicit functions on how to differentiate them. Make sure you like, comment, share to your fellow friends, and subscribe to the channel for notification on more tips for other courses. Thank you so much. Have a nice day. Thanks for watching.